Hello everybody, my name is Patricia and I'm here today to explain to you how the concept of related rates works. Related rates is a calculus application that involves finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. Okay.
This is boring.
Hello again, this is Patricia here with an amazing team. Please allow me to introduce my son Patrick, who got a diploma at school saying he does math like magic.
Oh no, Mommy, don't say that. Just say that I go to school and I play a lot of video games.
Okay, Patrick, who goes to school and plays a lot of video games.
Hello.
And also allow me to introduce my daughter, Chloe, who's also the executive producer for this video. Say hi.
Hi.
Today, we're going to explain to you how related rates works. And for that, we're going to use an example of a ladder sliding against a wall. It seems I didn't think that through. How we're going to do that?
Oh, I know, Mommy. We can do it like a movie.
Great. So, Chloe, let's do this. You're going to stay here in charge of the casting for the movie, for the Lego movie, and we can go to Legoland and find out how to make one. Good?
Good.
Let's do it. So, we just came back from Legoland. And now, do we have our casting ready, Chloe? Nice! The next step is to build the set, or in this case, the house with the wall and the ladder. So now, we already built the house. Look at our house, how pretty it came out. With the ladder that we're going to use for our example. Are we ready to go to Lego? Let's become a Lego.
Hi guys, it's me, Patricia, or the Lego version of me. So, this is our house, and over there is our ladder with our construction guy at the top working on the roof.
Hello, everybody. Don't get confused with the voice, okay? I'm a construction man, not a kid.
Patrick, be careful please.
I'm gonna be Batman. I'm the giraffe guy. I'm Rex. And you know what? I have a raptor.
Oh, then if you're Rex, I'm gonna be Wild Style. Shoo, go away. So, as I mentioned before, we're going to use an example of the ladder sliding down against the wall to show how the concept of related rates work. Basically, related rates or derivatives is just the relationship between rates of quantities changing over time. It explains how one rate of change affects the other one. In our example, we need to see the relationship between the rate at which the upper side of the ladder slides down and the rate at which the bottom side of the ladder moves away from the wall. Okay, so now let's take a closer look at the house. And please ignore the raptor. Sorry about that. So, here is our example. A ladder of length 27 feet that is leaning against the wall has its upper end sliding down the wall at a rate of 1/6 foot per second. A. At what rate is the bottom of the ladder moving away from the wall when the top of the ladder is 6 feet from the ground? B. What is the rate of change of the measure of the acute angle made by the ladder with the ground when the upper end is 6 feet above the ground? So, we're going to divide our problem in two parts, A and B, and we're going to follow 5 simple steps that you can use with other problems similar to this one. We're going to follow the 5 steps through part A and then part B. Let's go back and read again part A. At what rate is the bottom of the ladder moving away from the wall when the top of the ladder is 6 feet from the ground? Step 1. We need to draw a picture of the scenario and assign symbols or letters to the variables in our problem. So, once we have our picture, in this case, you can see a right triangle that is formed between the wall, the ground, and the ladder. Our ladder would be the hypotenuse, which is a constant in this case, 27 feet long. And then we assign variables to the wall, W, and to the ground, X. Both variables, W and X, represent rates that change in function of time. Therefore, we can also write them as dx dt and dw dt. The x dt represents the rate at which the distance between the wall and the bottom of the ladder is changing with respect to time. The same way, the w dt represents the rate at which the top of the ladder gets closer to the ground. Step 2. Write the information that is given on the problem in terms of variables. This way, you can see what is the rate that you need to find. For now, the information we have from the problem is the length of the ladder, 27 feet long, and is a constant. Our rate, dw dt, negative 1/6 feet per second. And the reason it's negative is because the ladder is sliding down and is a vector. So our question is, what is the rate of dx dt? And this is the rate we need to find. Step 3. Find an equation relating the variables w and x that we got from step 1. Let's take a look at our ladder again. As I explained before, there is a right triangle here, so we can use the Pythagorean theorem to relate the two variables x and w. X squared plus w squared is going to be 27 squared, our hypotenuse. Step 4. Differentiate both sides of the equation. This new equation will relate both rates. So now we're going to use one of the differentiation rules called the chain rule to get the derivatives of both sides of the equation. Always keep in mind that both w and x are variables changing with time. So do not substitute these variables until you finish the differentiation part. Otherwise, you're going to get the incorrect results. So, doing the chain rule, we get the final result, x multiplying dx dt plus w multiplying dw dt equals 0, which is the same as saying x dx dt equals negative w dw dt. This is the equation that summarizes the relationship between the two rates, dx dt and dw dt. Step 5. Substitute unknown values into the equation. This way, we can solve for the unknown rate of change. We're ready to substitute. However, we still don't have the value for x. So, we're going to use our Pythagorean theorem again to find x when w equals 6 feet. So x squared plus w squared equals 27 squared. And that at the end will give x equal 3 square root of 77 feet. So now we're ready to substitute in our related rates equation. So dx dt, it's gonna be equal negative w over x multiplying dw dt. When we enter the values and the signs, and we get rid of the signs and simplify, then at the end we have dx dt equals 1 over 3 square root of 77 feet per second. Please always remember to keep the units of measure. It's very important to keep track of the units so you know what is the final unit of the rate you're getting. Now let's go to part B. What is the rate of change of the measure of the acute angle made by the ladder with the ground when the upper end is 6 feet above the ground? We use the same 5 steps we used on part A. So step number 1 is picture the scenario. In this case, our scenario of the wall with 6 feet, our W in this case, still the same, and the rate still the same. The ladder also still the same. So we have more information than we had for part A. It's gonna be easier this time. Just picture what the angle will look like. In this case, we're gonna call the angle alpha. Step 2, we gather all the information we have from the problem and part A. So we know from the problem that dw dt, still the same rate, equals negative 1 over 6 feet per second. We also know w, 6 feet, and we know the hypotenuse, 27 feet, which we're gonna call h. Then from part A, we got dx over dt, which is equal 1 over 3 square root of 77 feet per second. And we also found x, which is 3 square root of 77 feet. Now what we need to find in this part is the rate of change d alpha dt, which is how alpha changes with respect to time as the ladder slides down the wall. Step 3. Find an equation that will relate the variables in this case, w and alpha. In this case, we can use the trig functions because we have a right triangle. So we can say that sine of alpha equals opposite over hypotenuse. In this case, w over h, and our h is a constant, 27 feet. So it's safe to say sine of alpha equals w over 27. Step 4. Differentiate both sides of the equation and use the chain rule. Once we differentiate both sides, we get on one side cosine of alpha that multiplies d alpha dt equals 1 over 27 dw dt. Then we move the cosine to the other side dividing, and we know that the cosine, using the trig functions, it's gonna be x over hypotenuse, or x over 27. So when we simplify, the final equation will be d alpha dt equals 1 over x that multiplies dw dt. Step 5. Substitute all known values. When we substitute our values, we know dw dt and we know x. At the end, we're gonna get d alpha dt equals negative 1 over 18 square root of 77 feet per second. So this is it. Hope you enjoyed this video. Let me know if you liked it. Bye.